Hey, welcome. We're talking about distance between coordinates. Again, we've talked about finding the distance of maybe 2 points, a -3 and an 8. But in this case, we're looking at distance between coordinates on a coordinate plane. So let's say we're looking at a point -2, 4. And we're looking at a point for -3 here. So basically, what was this? 4, -3. Basically, looking at this, we understand that there really isn't any way I could count units on a diagonal. My units are given in a vertical and a horizontal fashion. So basically, in order to find the distance between 2 points on a coordinate graph, what you guys are using or going to use is a version of the Pythagorean theorem, in which we'll be going over in tremendous and great detail later in the year. But basically what that's talking about is a square of your change in y and your change in x. Remember, we identified to find the change or difference in 2 points, you subtract. And that's what we're doing the same thing here. We're subtracting our x's and our y's to find the change. And this is the formula you'll be using to find the distance. And, setting that up is just basically saying, okay, my change in x's and then my change in y's minus a -3 here, and I get -6 squared plus. Now what I like to do is just put the little symbol at the end instead of making this house each and every time. Actually, I don't need that parentheses. I needed one here, and that's minus a minus is a 7, so that gives me 7 squared, and then I get the square root of 36 plus 49. 30 plus 40 is 70, 6 plus 9 is 15. So it's some version of 85, right? This would be your answer, whatever the square root of 85 would be. And if you put out a calculator, it'd probably be maybe 9.3, but 9 point some decimal here, because square root of 81 is 9. Now I want to go over just another example where it actually works out pretty smooth. So let's look at if I just gave you coordinates 10 and 3, and I'm giving you coordinates 2 and -3. Now, we don't need to draw the graph each and every time. I can just set up my formula, the x minus x squared, the difference or change in my x squared plus the change in my y squared. And then I end up with the 10 minus 2 for my x's plus the 3 minus a -3 squared here. Again, when I substitute in a negative, I like to use these parentheses. It helps me with my signs. 10 minus 2 is 8 squared plus 3 minus a -3 is 6 squared. 64 plus 36 gives me square root of 100, so therefore my distance would be 10. And if I were to just graph that to show you guys, and we had 10 and 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 and 3 here, and then my 2 and -3 here. Actually, this should be 4, 5, 6, 7, 8, 9, 10 here. 10 and 3 should be here. And then my 2 and -3 would be here. And if I'm trying to find this distance, my change in y was 6. There was the 6. My change in x was 8. So that's where the 6 and 8 come from. And here's my right triangle, and if I were to do the Pythagorean theorem of a triangle with legs 6 and 8, this side here, which we'll later call a hypotenuse, would be 10. So basically, you know, when they're giving coordinates and asking for distance, you're just looking at these coordinates, x and y, plugging into this formula here, finding the difference, squaring them, adding them, and then taking the square root. If you need to find this on a calculator, use your second button and the button that says x squared, and you'll be able to see your square root button and find your square root on the calculator.